Hey everyone, and welcome back to The Explainer. Today, we're setting the stage to discover a radically better way to collaborate with AI. Look, if you've been working with AI agents or coding assistants, you already know that absolute magic of getting rapid results. But you probably also know the major headache of trying to actually manage those results as your project gets bigger. So today, we're moving way beyond casual chat and exploring the highly structured world of spec-driven development.
Okay, let's dive into this. Have you ever spent more time correcting an AI than you would have spent just doing the work yourself? Picture this. You ask an AI to write a report. It gives you a draft. Okay, not bad, but you ask for a bit more focus on business metrics. It rewrites it, but wait, now those technical details you loved in the very first draft, they're completely gone. So you ask it to add them back in, and suddenly, the whole structure is just a total mess. 20 minutes later, you're staring at a document that literally reads like 3 different people wrote it, and you realize, I really could have just written this myself. It's incredibly frustrating, right?
Well, here's our roadmap for today to fix exactly that. We're going to cover 1. The vibe coding trap. 2. Level 1, specs first. 3. Level 2, spec-anchored. 4. Level 3, spec-as-Source. And finally, 5. Choosing your level.
So what exactly is spec-driven development, or STD for short? Let's just strip away all the technical jargon for a second. STD is simply giving the AI the complete picture up front so it literally never has to guess. Think of it like drawing a fully detailed architectural blueprint before you let a construction crew start building a house. Instead of discovering your requirements through this endless, painful back-and-forth conversation, you just front-load all the context right at the start. All right, let's start with Section 1, the vibe coding trap, and exactly why casual chat fails for big projects. So vibe coding is the natural way most of us first start approaching AI. You have a kind of vague idea, you describe it, the AI generates something, and you just tweak it through conversation. You're basically just coding on vibes. But for substantial, serious work, this fails systematically. It inevitably leads to constant correction, the AI making blind guesses, and context just totally getting lost. Spec-driven development, on the other hand, replaces that frustrating loop with upfront blueprints, explicit constraints, and precise execution. The AI actually gets it right the very first time because you gave it all the rules of the game up front. So the crucial point is understanding exactly how vibe coding fails, and it usually breaks down in 3 very specific ways. First up is context loss. As you iterate, the AI focuses on your newest requests, and all those little nuances you set up in turn 1, they just fade into the background noise. Second, assumption drift. If you don't give the AI explicit constraints, it's going to fill the gaps with reasonable but often totally wrong defaults. Like, it might guess you want a casual blog post when you actually needed a heavily cited research report. And third, pattern violations. Without knowing your specific standards, the AI might just follow general best practices that completely contradict your project's unique setup.
Which brings us right to Section 2, Level 1, Spec-First, also known as the Disposable Sketch.
Spec-First is absolutely the easiest and most common way to use this framework. Here's how it works. You write a specification to guide the AI implements it perfectly, and then you just throw the spec away. It just becomes a historical record. This level is fantastic for quick, single-session tasks, minor bug fixes, or those solo weekend projects. The massive benefit here? Absolutely zero maintenance overhead. You write it once, the AI implements it once, and you're done. The catch, of course, is that 6 months down the line, you won't have any documentation to remind you of what you actually did.
Let's really ground this with a clear running example. Imagine you need to create a business report on personal AI employees in 2026. In Level 1, you'd write a quick spec defining the audience, let's say CTOs, requesting specific tool comparisons, and demanding a highly professional tone. The AI reads this spec and drafts the report perfectly on the very first try. You publish your report and boom, you delete the spec file. It's simple, it's fast, and it's super effective for a solo task.
But as projects scale, we need something way more permanent. Welcome to Section 3, Level 2, Spec-Anchored, or the living architectural blueprint. Now, what's really interesting about this slide is how the specification evolves from a quick throwaway sketch to the ultimate source of truth, and it stays permanently linked to the output. In Level 2, both the specification and the output, whether that's a piece of code or a written document, are maintained together. If your requirements change, you update the spec first, and then generate the new output.
This is absolutely essential for teams, complex systems, or honestly any project with a lifespan longer than 6 months. It basically serves as living, breathing documentation.
Let's look at our AI report example again, but let's evolve it to level 2. Say 6 months have passed, and you need to add a newly released AI tool to your comparison. Now, instead of just opening up a chat with the AI to haphazardly jam the new tool in there, you open your saved spec document. You update the spec's requirements to include this new tool. The AI then implements those exact updates into the final report. Finally, you save both files together. Because you did this, a brand new analyst joining your team tomorrow can just read the spec and instantly understand the exact methodology behind your report.
All right, now we're stepping into the really bleeding-edge frontier of AI automation. Section 4, Level 3, Spec-as-Source, or the fully automated 3D printer.
The appeal of Level 3 is literally massive. In this model, the specification isn't just documentation anymore. It is the primary artifact. You only ever edit the spec. You never ever manually touch the final code or the final document yourself. When you want to change, you just update the spec, and the AI completely regenerates the final output from scratch, on demand. It is insanely powerful for highly repetitive tasks, disposable scripts, or totally experimental environments.
And this brilliantly illustrates the major pitfall of Level 3. Why isn't everyone just doing this for everything? Well, it's because of the determinism problem. Identical specifications do not produce identical code. If you ask an AI to implement the exact same spec twice, you are going to get functionally equivalent but syntactically different results. Things like variable names might suddenly change, or helpful comments might just disappear. For a live production system, this means every single regeneration creates a massive, totally unpredictable changelog, which makes debugging an absolute nightmare.
But for the right task, it's pure magic. Let's look at the final evolution of our AI report. Imagine this report actually needs to pull live API data and be published every single week. In Level 3, you only edit the spec to point to the new data sources. Then the AI completely auto-generates a brand new, beautifully formatted report from scratch. You literally never open the final document to tweak it. You just repeat this regeneration weekly, completely trusting your spec to handle all the heavy lifting.
Okay, we've covered a ton of ground today. Let's transition into Section 5, Choosing Your Path, and figure out exactly when to use which level.
Let's move to and see how this builds. Here, we have a clear master decision matrix summarizing everything we've just learned. Take a mental screenshot of this. Level 1, Spec-First, requires absolutely no maintenance and is perfect for solo tinkerers and quick one-off tasks. Level 2, Spec-Anchored, requires double the maintenance since you're maintaining the spec and the output, but it's practically mandatory for teams and creating living documentation. And Level 3, Spec-as-Source, requires maintaining only the spec, leaving the output entirely automated. But honestly, it should be reserved for those experimental frontiers and highly repetitive work.
The main thing you should take away from this is that you do not need to pick one single level for everything you do. Think of this as an evolutionary journey, right? Start with Level 1 today, just to break free from that frustrating vibe coding trap. Then, when you're working on something you know you'll need to maintain for months, graduate to Level 2. And as you get more comfortable, find those safe, repetitive little corners of your work to start experimenting with Level 3.
Which leaves us with a truly fascinating question to ponder. As AI models become more and more deterministic and reliable, will we eventually stop building final products directly altogether? Will the entire future of human work simply be writing the perfect blueprints and just letting AI handle the rest? It's a profound shift in how we create things, and mastering spec-driven development today puts you right at the forefront of that future. Thanks so much for joining me on this explainer, and I'll catch you next time.